In the previous video, we have derived two important equations for the transformer. One is EP by ES, that is equals to N1 by N2, and IP by IS, that is equals to N2 by N1. Now let us proceed to the more deep in the construction and the working principle of the transformer. So this is a core of the transformer. Now this is the primary winding, and let us say this is the secondary winding. So you are giving, we are applying EP over here, current IP, and this is ES, that is IS, I secondary. Now as soon as you are applying the voltage, there is a flow of flux in the core. This is the core, it is in this direction. That's how the flux flows. Now we have mentioned previously that the input power of the transformer, that is equal to the output power of the transformer. But in practical cases, we can find that there is some loss while the flux is traversing from the core. Now what are the losses? The losses are known as core loss. Core loss is one, hysteresis loss, and another one is eddy current loss. Now hysteresis loss occurs among all the magnetic materials. The magnetic materials, this core is made of a magnetic material. Remember one thing, that core is made of magnetic material but not conducting material. If core had been made a conducting material, then you can see that there is a flow of large current in the core, because you can see this is the flux is flowing in this way, so there will be a production of current also given by the right hand grip rule. So the core is made of such material like ferrites and CRGO and CRNGOs, ferrites. These materials have good magnetic property, but their conducting property is low. So in hysteresis loss, suppose we are plotting the BH curve for the hysteresis loss. Now in BH curve, this is the field intensity and this is flux density. Now suppose if we apply some field intensity, so the flux density will rise and then it will saturate. Now we are withdrawing the field. What will happen? It will come in this direction. No, it will not come in this direction. First it will go like in this way. Here you can see the intensity is 0, but the flux density is present. Again we are lowering the field intensity. Here you can see the field intensity is 0, the field intensity is negative, but the flux density is present. So again we are lowering, coming here, again a saturation occur here, and again if we apply a certain field, then it is 0 again. This loop is known as the hysteresis loop. hysteresis loop. In hysteresis loop, the slope of the loop, that is B by H, which is mu. Now, in ideal cases, in vacuum, B by H curve is a straight line curve, like this, BH, where mu is a constant, because mu, the slope is always constant in a straight line. But here, mu is not constant. So, we can say the area given by this loop will be B into H, that is our hysteresis loss. So hysteresis loss is present for all the magnetic material, which is the core is made up of the magnetic material. So there is hysteresis loss. And in the case of eddy current loss, let me go to the next page. Eddy current loss, how eddy current loss occurs? Suppose we are drawing the three-dimensional view of the core. This is the core. This is core, and this is how the core looks. And if we can take the cross-sectional view of the core, which is like this. This is the cross-sectional view of the core. Now, the flux is traveling like this. It is traveling like this. So again, according to the right hand grip rule, there is a production of current in this cross section, like this. Like this, the production of current as the flux is flowing in this way. So as these are circular currents and the current is produced due to the flux, these currents are known as eddy currents. So these currents also contributes to the loss of the transformers. So to reduce this current, what we do, we laminate the core. How this lamination lowers the losses? We laminate the core in this way. So you can see, if we take this cross section, now we are laminating the core, so the cross section area is decreased. The cross section area is decreased, and as the cross section area is decreased, the resistance, which is equals to rho L by A, as A is decreased, resistance is increased. As resistance is increased, according to the Ohm's law, the current will be less. That's how we eliminate the effect of, not completely eliminate, but try to reduce the effect of eddy currents. Okay. Now, in hysteresis loss is proportional to the field intensity, the flux density, the core volume, and the frequency. What is this frequency? Frequency is the supply frequency. The supply frequency is a AC supply. So this hysteresis loss is proportional to B, core volume, and frequency. So as the core volume increases, the hysteresis loss also increases. As the frequency is increased, the hysteresis loss is also increased. And for eddy current loss, current loss. Eddy current, in the case of eddy current loss, which is proportional to B, the core volume, and frequency square. So if we increase the frequency, then the eddy current loss will increase at a greater extent. So these are the constant losses in a transformer. Constant losses means whether you change the circumstances of the transformer, that means supply voltage, supply current, these losses will be always present. So this is known as the constant losses in the transformer. And there are another kind of losses which are known as the variable losses. What are these losses? These windings of the transformer are made up of copper wires. So as the current is flowing in these copper wires, there will be a I square R loss in the copper. There will be a I square R loss in the copper, both in primary and in secondary. So the power input is equals to the power output plus the losses in a transformer. This is not ideal transformer, this is the practical transformer. In practical transformer, you can see this P input is equals to P output plus losses, but in ideal transformer, P input is equals to P output. So P output plus losses means variable losses. These are variable losses. Why these are known as variable losses? Because if you change the circumstances of the transformer, that means input voltage, output voltage, then this current will change. As this current will change, resistance keeping constant, this loss will vary as the current will vary. So these are the variable losses. So variable losses plus constant losses. So variable losses, which is I square R loss, or it is known as copper loss, or it is known as ohmic loss. And constant losses are hysteresis and eddy current loss. So we'll continue transformer in part 3.